Welcome back, physics fans, and here we are doing a conservation of energy question. A cart on a track has a mass of 40 kilograms and an initial velocity of 10 meters per second. As it travels down the track, it loses 1,000 joules to heat, probably because of friction, as it reaches the end of the track, which is 4 meters below where it started. So that's 4 meters below. Determine the final velocity. So to attempt this, we write down that the energy before equals the energy after. This is stating that you know it's a conservation of energy question. Then the energies that are involved are kinetic energy, because there's a speed, and the potential energy because of the height, and it even mentions that there's heat energy, so we have to include that in there as well. So the potential energy initial plus the kinetic energy initial has to equal the potential energy final plus the kinetic energy final, and the place where the heat went to, the heat energy over there. So the initial energy that it had, it's moving and it has a speed. So neither of them are zero. The potential energy final, we're going to set to zero. It doesn't have to be, but we're going to set the potential energy 0 point to be here because we have to measure with respect to a particular location. So we're going to set the potential energy to 0 at the final. So let's plug the numbers in, or at least the variables in. So it's mgh plus 1/2 mv squared is equal to, that is 0, so it's just going to be 1/2 mvf squared plus the heat energy. Now, do not cancel out the masses because heat energy doesn't have an m in the formula. In fact, we don't have the formula for it, so you can't cancel out the m's. Okay, so it is a 40 kilogram cart. 9.8 newtons per kilogram is the gravitational field strength, and it's a height of 4 meters. This is going to be clear. That's going to be 40 times 9.8 times 4 is going to be 1568. And that unit will be joules. And then this is going to be 1/2 40, and its initial speed is 10 meters per second, and that's going to be squared, and that's going to equal 2,000. So this is an important number here that I'm going to be writing down here, 3,568 joules. That's on the left-hand side. That's the energy before. That's the energy before. That's an important number because we're not adding energy to the system by pushing it or rockets. So that is the energy that it starts with, which is the energy that it ends with. It has two different localities where it can go into, two different types of energy. It goes into kinetic energy and heat energy. So this is going to equal 1/2. The mass is 40, and we don't know VF. Okay, let me just move that over a bit. Yeah, let's just... And then I have to add the 1,000 joules that was lost to heat energy. It does say lost. Don't put a negative there. Lost meaning that it was in potential and kinetic beforehand, and it loses it to heat energy, which means heat energy gains it afterwards. This will always be a positive number over here, because friction will never add energy to kinetic energy. It always takes away. So this is going to be 20 VF squared plus 1,000. And then we subtract 1,000 to both sides, and we get 2,568 joules is equal to 20 VF squared. I'm going to go over here now, and that's going to be add 2,000 to this, subtract 1,000, because that was the total energy. 1,000 went to heat energy, so this number is an important number. What is this blue number? It's not the total energy. Think to yourself for a few seconds, what does that number represent? That's the kinetic energy final, because 1,000 went to heat energy and 2,568 went to kinetic energy final. So now that we have the kinetic energy, all we have to do is find out what the velocity is. So I divide it by, well, it's actually dividing it by 40 and multiplying it by 2, 20, and then take the square root. Oh, did I do it wrong? And that's it. So VF is going to equal 11.33 meters per second. And that is going to be a scalar. We'd say as drawn in the diagram if they needed a direction, but that doesn't really matter. And if by chance the cart fell off the track right at the beginning and hit the ground, that would also be the velocity that it would hit the ground at, especially if it fell off going down at 10 meters per second. And it still lost 1,000 joules to air friction or something like that. Thank you very much. Hope you enjoyed it. Subscribe, smash that like button.